What is CIDR and why this CIDR is used? Everything starts from IPv4 addressing scheme, Internet Protocol version 4. So what was the problem? Why we are coming to or gone to CIDR? So this is CIDR, and this address you will understand what is this. If you know the problem, you will be able to understand the solution. Now just consider an organization, and class C it is using, and 2 to the power 8 because last 8-bit host 256, first and last we cannot use. So maximum possible host can only be 254. But when this organization decides, okay, I want 500 IP addresses. But when you shift from C to B, because you just have to shift from C to B. So now the addresses of the host becomes 65534. Because that number 500 will be computer, tablet, whichever device you want to put as a host. But this number is very big. You just wanted 500, this organization wanted 500, but the availability is 65534. So what will be the wastage? Wastage will be immense. So private and public and 127.0.1, all these kind of addresses. So there is always a wastage in classful addressing. So this is the problem in classful addressing. There are millions of class A, then we have class B addresses, various class B addresses, class C addresses, and class C addresses are too small. Sometimes the organizations, they find it very small. So in order to get rid of this or to solve this kind of problem, classful networking is now gone to CIDR, which is classless interdomain routing. Classless interdomain routing, we also call it as supernetting. This is CIDR. So this is a way, this is a method of assigning IP addresses that will improve the efficiency of address distribution, which we just saw in the example. And it also replaces the previous system, which was actually based on different classes. And class is fixed. Class is fixed. So this /12 will give you what? It will give you the network address. So the basis of CIDR is nothing but VLSM, that is the variable length subnet masking. If I say A, class A, you will say, oh, I know the subnet mask 255.255.255.0. If I tell you B, you will say, oh, I know it 255.255.0.0. That is the subnet mask default. Again, for C, it is 255.0.0.0. There is no subnet mask for D and E. But what if that you don't want this? You want a contiguous addresses for your organization to fulfill their requirement. You need a network address, you need a host address similarly or same as the previous one. And similarly for that matter, we want the system to remain same. So the whole network and the host inside that network. So this is the numerical masking, which is actually a kind of subnet masking only. So this numerical masking sequence allows the network administrator, those people who are handling this administrator, to break down an IP address space into subnets of their organization requirement of different sizes. So this is CIDR. Now what is this IANA? Now the question will be, if you start assigning different block of IP addresses to different companies, private networks, there will be some clash, there will be some problem. How are you going to do that? Who is the director? Who is going to take care of that? Because private network may want the same number of the block can be provided to them. So the authority is the Internet Assigned Number Authority, which is also called as IANA. And this IANA assigns the larger blocks to whom? RIRs. This is Regional Internet Registries, RIR. Now in turn, this RIRs, they all create smaller blocks and then they assign them to whom? LIRs, local internet registries. And see, you have Fido or Airtel or Geo, you may have different service providers. So these are internet service providers. So this internet service provider is now in charge, after all these being done, of assigning the blocks to the end user, because you are actually paying to ISPs, not to INA. So for any private network, ISP will provide. So this /12 is simply the first 12 bit will be 1 1 1 1 1 1 1 1 and this 8 1 1 1 1. So it will be 12 1 1 1 1 and this will be ANDed with the IP being given and then you will get the network address. So this address, this is a CIDR address. This is also IPv4. So this CIDR doesn't look different. It is just like a normal IP address. Just the difference is it ends with a slash which is followed by a number. So the number which is coming after the slash, what it is representing? It is saying you the number of addresses in that range. So this IPv4 we are talking about, it is 32-bit address. This also CIDR is also a 32-bit address. And it also has a special number which represent the number of bits that are present in a block ID. For example, A, let me write it here, A.B.C.D and then slash a number n. And this n is what? This is the number of bits that are present in your block ID or network ID. You can call it as a network address, but we don't call it here. This is a network address only. That is, these are the number of ones, 12 number of ones are to be placed from left and then the network address is to be computed or determined. Let us consider an example. The example is 123.45.67.89/12. Now this IP address contains two groups. What are the two groups? The first part from here to here, this is called the network prefix. This is a binary configuration of a network address because this is a decimal number, right? Dotted decimal form. IPv4 is represented like that only. But this is called as the binary configuration of the network address, and the /12 is called as the suffix. And this is indicating how many bits, how many number of bits are in the entire CIDR address. So we'll also take an example just now. But before that, this is IPv4 123.45.67.89. What do we do? Inside it is converted into binary and these binary numbers are ANDed and ORed in order to compute the network address, the subnet ID and the other things like the broadcast ID. So you need to go to a network and then you have to find out how many hosts or what is the host ID. So IPv4 addresses are 32 bits long. From this example or this consideration, we have how many? 12, the first 12 bits, it is representing the network address. So the first leftmost bit, or you can say here it will contain 2 octets. So 11111111 and 1111, that is 4 11 in a combination called as 12 bits. So in all it is 12 bits. The others will be for the other purpose, but this is for the network address. The 12 bits, the 12 11 bits. So if you have 32-bit address, it is, and you subtract this 12 from that, what do you get? You get 20 bits, and this remaining 20 bits, they are representing how many host addresses are available. For this example, it is quite huge. So you have a network, and when you make a CIDR, that is, it is always pointing to only one network, one subnet, right? So 2 to the power 20, these hosts can be there. So every network by default has only one subnet containing all host addresses. Okay. So this subnetting that is dividing into another parts of the subnet is done by the network administrators. Let us take an example of CIDR. CIDR has certain rules. Classless interdomain routing. we have seen IPv4 addressing A, B, C, D, E. So here the rules are different. And with these rules, we'll try to understand the rules with respect to an example, considering an example. So we have to check whether this IP till this IP is a valid IP address block or not. And we are talking about CIDR. There is no slash given, but always a CIDR address will be having an IP address followed by a slash with a number. These number will compute the network address. First rule is all IP addresses must be contiguous. What does it mean? If I write 1, 2, 3, this is contiguous. If I write 1, 2, 4, no, 3 is missing, so it is not contiguous. Contiguous means one by one, like the array being stored. So we have to check for this. Now you compute. Next will be what? 100.1.2.33, then 34, 35, 36, 37, 38 till 47. So these are all contiguous. The first thing rule is true here. All the IP addresses are contiguous here. So the first thing is contiguity. This is the first rule for CIDR. Coming to the second rule. The second rule is the block size must be of the power of 2. Now we'll ask why? Because if the size of the block is of the power 2, it will be quite easy to divide the network. We are dealing in computer science only with 2 to the power something. So finding out the block ID is quite easy. So take an example, if you have 2 to the power 5, that is you have the block size is 2 to the power 5, that is the host ID will contain 5 bits. If you take 32-bit address, the last 5 will be the block size. So if 5-bit is this one, how many network bits will be there? 32 minus 5 will give you 27. So 27 network bits and this 5 are for the host bits. So this is how this will be formed. And this is of the power of 2. That is very important in this CIDR. So now you just go from 32 to 47 counting. That is 32, 33, 34. If I am counting on my hands, it is becoming 16. 32 to 47 is 16. What is 16? Is 2 to the power 4. 16 is nothing but 2 to the power 4. So this for power 4, that is total number of IP addresses in the block, will be 16. 2 to the power 4 in this case, with the example we are taking. If you count also, you will get it. Now, this 2 to the power 4, that is this 4 is what? 2 to the power 4, 4 power. So 2 to the power 4 is 16. That is this is of the form 2 to the power n. The third rule is the first IP address of the block must be evenly divisible by the size of the block. What does it mean? The least significant part should always start with zeros in host ID. Because all the significant bits of the host ID is 0, then we can say that this is the block ID part. So we assume in this case that 100.1.2.32 is our first ID of the network, or it actually indicates the network. So 2 to the power 4, what does it mean? We have 4. In this case, we have 4 bits for the host ID. So this is 4. How many are remaining? 32 minus 4. That is going to be 28. Now what you have to see here is, you just have to see the last 4 bits. If they are 0, then you will say it is divisible. I'll tell you again. The third thing is saying the divisibility should be complete. So if we have 100.1.2.32, forget about 100.1.2. This 32, just write it in the bit form. That is the binary form. So 0, 0, 1, 0, 0, 0, 0, 0. So 1, 2, 4, 8, 16, 32. So it is correct. Now, when you see here 4 bit, so you have to start from the right. See if all the 4 bits are 0 or not. If this is 0, you will say, oh, it is divisible. If it is 5, then 1, 2, 3, 4, 5. Oh, again it is 4 zeros are there. It is divisible. What if it is 6? You'll say, no, there is a 1. So that is not all zeros. We don't have 6 zeros. So it is not. So in this case, the third rule will not be followed. In this case, we have all these being followed. So if you just want to write how this address will be in CIDR, So the way of forming it, if you assume that 100.1.2.32 is the network address, that is it is indicating the network. So 100.1.2.32/28, which is the network address, network ID or network numbers, this is the answer.